Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter Thermodynamics. So any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Um, Also, if you have more difficulty in any other chapter of chemistry, then please mention the name of that chapter also in the comments section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions will be uploaded in the Sapience Education application. So please install our Sapience Education application whose link has been provided in the description. So here it is told that the lattice enthalpy of NaCl is plus 788 kilojoule per mole, and the hydration enthalpy is minus 784 kilojoule per mole. Then the enthalpy of solution is so we know that the enthalpy of solution that is equal to the lattice enthalpy plus the hydration enthalpy. Since why the enthalpy of hydration suppose for NaCl, it means that Na sodium Na plus in the gaseous form that will form Na plus in the aqueous solution. So here we have hydration enthalpy for NaCl. It means that Cl minus in the gaseous form will also convert into Cl minus in the aqueous form. So here we have hydration enthalpy, and lattice enthalpy is when Na plus in the aqueous solution plus Cl minus in the aqueous solution that will be converted to the NaCl in the solid form. So here we have lattice enthalpy. And the solution enthalpy is that from the gaseous ions, the solid NaCl will be formed. That was called the solution enthalpy. It means that Cl minus gas plus Na plus gas in the gaseous ion that will convert to NaCl solid. That is called the solution enthalpy. So if we add these two, hydration enthalpy and lattice enthalpy, then we will get solution enthalpy. So solution enthalpy for NaCl that will be equal to 788 minus, so plus of minus 784 kilojoule per mole, that will be equal to 4 kilojoule plus 4 kilojoule per mole. So option D is the correct answer. Then here it is told a gas at a pressure of 2 atmosphere. So there is a gas which is at 2 atmosphere pressure. It is heated from T initial equal to 25 degrees Celsius to T final, that is 323 degree Celsius, and simultaneously it is compressed to two-thirds of its original value. Then the final pressure is, so it means if the initial volume is V, then the final volume is 2 by 3 V. It is compressed to two-thirds of its initial original value. So then the final pressure will be how much? So the final pressure has been asked, and P initial is 2 atmosphere. So now, therefore, we can say that PV equals to nRT. So PV by T will be equal to constant. Since why here the number of moles of the gas is kept constant. So therefore P initial V initial by T initial that will be equal to P final V final by T final. Now P initial is 2 atmosphere times V initial, that is V, by T initial it is 298 Kelvin. That is equal to P final, we have to find out. and V final, that is 2 by 3V, divided by T final, that is 323 plus 273 Kelvin. So that is equal to 596 Kelvin. This is equal to 596 Kelvin. So here 2V and 2V will get cancelled. This will be equal to 1 by 298. That is equal to P final by 3 into 596. Now 298 into 2, that is equal to 596. So P final, that will be equal to 6 atmosphere. So option D is the correct answer. Then here it is told 1 mole of oxygen at 273 Kelvin and 1 mole of sulfur dioxide at 546 Kelvin are taken in two separate containers. Then the kinetic energy of O2 and the kinetic energy of SO2 we have to compare. So the kinetic energy that is given as mm, that is equal to half. So the average kinetic energy that is equals to, now the average kinetic energy that is equal to the internal energy. So that is equals to F by 2 nRT. The average kinetic energy that is equal to the internal energy only of the ideal gas, that is equals to F by 2 nRT. Now, where F is the number of degrees of freedom of the gas and N is the number of moles of the gas and R is the ideal gas constant and T is the absolute temperature of the gas. Now, therefore, the kinetic energy of oxygen, so that will be equal to, so for a diatomic gas, the degrees of freedom is 5. So 5 by 2 into, that will be N, that is 1 into R into T. T is equal to 273. And similarly, the kinetic energy of sulfur dioxide SO2, so that is a triatomic gas. So the degrees of freedom will be 6 here. So 6 by 2 into 1, the number of moles is 1 into R into T. T is 546. So now, therefore, the kinetic energy for oxygen divided by the kinetic energy for SO2, that will be equal to, this is 5 into 273 into R by 2 divided by 3, 3 to the 2, 3 is 6, so 3 into R into 546. So R and R will get cancelled and 273 into 2 is 546. So this will be equal to 5 by 4, 3 is 12. So 5 by 12. So therefore kinetic energy of oxygen, that is less than kinetic energy for sulfur dioxide. So option 2 is the correct answer. Then here it is told which of the following is an intensive property. So intensive property, it means, so intensive property, it means properties, those thermodynamic properties, those thermodynamic properties which are independent of the amount of particles, which is independent, which is independent of the amount of particles in the system, which means which is independent of the size of the system, which is independent of the size of the system. So, so as we know, temperature will be an intensive property only, since it is independent of the amount of particles in the system. Then surface tension also, it will be independent of the size of the system. And then viscosity, or I can say the coefficient of viscosity, that is also independent. So it means all of these are independent, all these three are independent. uh, all these three properties are independent of the size of the system. So they all are intensive properties. So option 4 is the correct answer. Then it is told the entropy of the universe is constantly is so it is continuously increasing. So the entropy of the universe should increase. Entropy of the universe is increasing, which is according to the second law of thermodynamics. Which is according to the second law of thermodynamics, which says that the entropy of any isolated system will always increase. Entropy of any isolated system, entropy of the entropy of any isolated system always increases. So the universe can be assumed as an isolated system only. So its entropy should always keep on increasing. So option 1 is the correct answer. Then here it is told, considering the reaction carbon plus O2 gives CO2 gas plus 393.5 kilojoules. So it will release this much amount of heat. So therefore the the change in enthalpy is minus 393.5 kilojoule per mole. So it means that the change in enthalpy is negative, since why it is an exothermic reaction. And then here delta G should be negative also, since the since all the combustion reactions are spontaneous. Since the combustion reaction is always spontaneous reaction, and so as we know, delta G equals to delta H minus T delta S. So it means that T delta S will be equal to delta H minus delta G. Now delta H is negative and delta G is negative also. So now, so it means that if for all at all temperatures, uh, delta G should be negative only. So it means that delta S should be positive, since this combustion reaction is spontaneous at all temperatures. It is spontaneous at all temperatures. So the sign of delta H and delta S and delta G, that should be negative, positive, and negative. So option 1 is the correct answer. Then here it is told that in which of the following processes, which of the following process a maximum increase in entropy is observed. the dissolution of salt in water, it means uh, the salt, suppose for example NaCl in the solid form, it is going into the aqueous solution form. And in the second case, condensation of water, it means that water in the gaseous form or in the water vapor form that condenses into the liquid form. So as we know that solid has got the least en entropy, and liquid has got slightly higher entropy than that of solid, and gas has got much higher entropy than solids or liquids. So gas has the maximum randomness or disorderness, maximum randomness, so it has got maximum entropy. So here also the entropy, here the entropy decreases, and here also the entropy increases. But in the third case, sublimation of naphthalene, so naphthalene in the solid form that will go into the naphthalene in the gaseous form. Naphthalene vapor it will form, which is the gaseous form. So here there is maximum increase in the entropy since solid is converted to the gas. And in the fourth case, melting of ice. So ice in the, so water in the solid form is converted to water in the liquid form. So here also the entropy increases, but here solid is converted to the gaseous form. So here we have maximum entropy increase, maximum increase in the entropy here. So option 3 is the correct answer. Then here it is told thermodynamic standard conditions of temperature and pressure are. So thermodynamic standard conditions are are, are 298 Kelvin and 1 atmosphere. The temperature should be at 298 Kelvin and the pressure should be 1 atmosphere. So option 3 is the correct answer. 101.3 kilo Pascal also, it is also called 1 atmosphere. Okay. But here it should not be 0 degree Celsius. The temperature should be 25 degree Celsius or 298 Kelvin. So it means the thermodynamic standard conditions, we can also say it is the the temperature should be 25 degrees Celsius and the pressure should be 101.3 kilopascal or 1 atmosphere. Then here it is told for a reaction to be spontaneous at all temperatures. Mm, here delta G should be negative and delta H should be negative also. And here delta S should be positive, so that at all temperatures delta G can be negative. So it means that delta G and delta H should be negative for all the for the reaction to be spontaneous at all temperatures. So option 1 is the correct answer. Then here it is told the temperature of the system decreases in an, so here in an isothermal expansion or compression, isothermal it means the temperature should remain constant. So here the temperature will not decrease or increase. So in case of adiabatic process, we have that PV power gamma that is equal to constant, or we can say PV equals to nRT. So I can write it is nRT into V raised to uh, power gamma minus 1, that is equal to constant. So I can say TV raised to gamma minus 1, that is equal to constant. So it means that T is equal to some constant. So, or I can say, so T is inversely proportional to V raised to gamma minus 1. So it means that for for adiabatic compression, we have that the volume decreases. Uh, so the temperature should increase. And here, and for adiabatic expansion, the volume increases, so the temperature should decrease. The volume increases, so the temperature should decrease here. So it means the temperature of the system decreases in an adiabatic expansion. Option 4 is the correct answer. Then it is told molar heat of vaporization of a liquid. The molar heat of vaporization, that is 6 kilojoule per mole. If the entropy change is 16 joule per mole per Kelvin, the boiling point of the liquid is. So we know that delta S will be equal to, so mm, that is molar heat of vaporization divided by T. So it means the entropy change, that is equal to 16 joule per mole per Kelvin, that is equal to um, enthalpy, the molar heat of vaporization. So that will be equal to 6000 joule per mole. So 6000 by T. So here, so T will come 6000 divided by 16. So that will be equal to, that is 4 for the 16, 15 for the 60, then 4 into 25, that is 100. So 15 into 25 Kelvin. So that is equal to 15 5 the 75 to the 30, 375 Kelvin. Or I can say that is 273. So it is 102 degree Celsius. So it is 375 Kelvin. So option 2 is the correct answer. So 375 Kelvin is the required boiling point of the liquid. Then here it is told for a system in equilibrium, delta G equal to 0 under the conditions of constant, that should be constant temperature and pressure. So the temperature and the pressure should be constant. So option 1 is the correct answer. Then it is told the cooling in refrigerator is due to the expansion of the gas in the refrigerator. So in the case of a refrigerator, here we have the expansion of the gas and there is no heat exchange. So, so there is adiabatic expansion. So when the volume increases, the temperature should has to decrease. So the cooling in the refrigerator is due to expansion of the gas in the refrigerator. So option 3 is the correct answer. Then it is told a mixture of 2 moles of carbon monoxide and 1 mole of oxygen in a closed vessel is ignited to convert carbon monoxide to carbon dioxide. So it will form 2 CO2. If delta H is the enthalpy change and delta E is the internal is a change in internal energy, then so here carbon monoxide is also a gas, oxygen is also gas, and CO2 is also a gas. So therefore, as we know that delta H that is equal to delta E plus delta Ng into RT, where delta Ng equals to the number of moles of gaseous products, the number of moles of gaseous products minus the number of moles of gaseous reactants. So here that will be equal to 2 minus 3, so that is equal to minus 1. So therefore here we can see that delta H that will be equal to delta E minus RT. So it means that delta H is less than delta E. So option 2 is the correct answer. Then here it is told the enthalpy of the reaction. So here hydrogen is reacting with 1 mole of hydrogen is reacting with half mole of oxygen in the gaseous states to form H2O in the gas state. So this reaction will be exothermic. This reaction will be exothermic. So here delta H1 is negative, and here also H2 gas plus half mole of O2 gas reacts to form H2O in the liquid state. So here this gaseous state of H2O is converting into the liquid state. So it will be more exothermic. So this reaction is more exothermic. It means that it will release more amount of heat than in the first case. In the first reaction, it will give out less amount of heat, and in the second reaction, it will release more amount of heat. So here delta H2, which is the enthalpy of this reaction, is more negative, is more negative. So therefore, if we compare the absolute value of these enthalpies, then mod of delta H2 will be mod of mod of delta H1. But if we use the sign, then since delta H2 is more negative than delta H1, so delta H2 will be less than delta H1. So option 1 is the correct answer, which says that delta H1 is more than delta H2. Then here it is told the enthalpy of combustion of methane at 25 degrees Celsius is 890 kilojoule. The enthalpy of combustion of methane CH4 at 25 degrees Celsius is 890 kilojoule. Then the heat liberated when 3.2 gram of methane is is burnt in air is. So here CH4 will react with O2 to form CO2 plus H2O plus some heat it will release. So 2 mole of H2O, then here it will be 2 moles of O2. Okay. So here so here so here it is told that mole 1 mole of CH4 releases this enthalpy of combustion is 890 kilojoule per mole. So it means 1 mole of CH4 releases 890 kilojoule of heat on combustion, on complete com on complete combustion. Then, therefore, 3.2 gram of CH4, that is how much mole that we have to find out. So it will be 3.2 gram divided by the molar mass of CH4, which is 12 plus 4, that is equal to 16 grams. So that is 16 2s are 32. So that is 0.2 mole. So therefore, the amount of heat released, the amount of heat that will be released on combustion, that will be equal to 0.2 mole times 890 kilojoule. So that will be equal to 89 into 2, that is 89 into 2 kilojoule, that is equal to 2 9s 18, 16, 178 kilojoule. So it means option, the heat liberated will be 198 kilojoule, 178 kilojoule. So option 2 is the correct answer. Then here it is told that a process is taking place at a constant temperature and pressure. Then, so it means the pressure is kept constant and the temperature is also kept constant. Then we have to find the relation in between delta H, delta E, delta S, and all that. So as we know that dH, that is equal to um, du plus P dV plus V dP, and and G equal to H minus Ts. So dg equal to dH minus TdS minus SDT. Now, therefore, dg will be equal to 0. Then we can say that dH will be equal to TdS. Okay. Now, mm, now from here we can see that, so now dH will come as VdP plus TdS. VdP plus TdS. So now if P pressure is constant, then VdP will be equal to 0 only. And since temperature is constant, so therefore dH I can write simply, that is will be equal to T ds. So it means delta H will be equal to T delta S. Since by delta G will be equal to 0 for any for any process which is taking place at e- equilibrium, at equilibrium. Yep. So option 4 is the correct answer. Then here it is told that for a reversible reaction, X in the gaseous form plus 3Y in the gaseous form uh, gives 2Z, 2Z in the gaseous form. Here the change in enthalpy of this reaction is minus 40 kilojoule, and the standard entropies, the entropy for X, that is 60 joule per Kelvin per mole, and the entropy, the standard entropies, and this one is also standard enthalpy change of the reaction. So here also the standard enthalpy for Y is 40 joule per Kelvin, joule per Kelvin per mole, and the standard enthalpy for Z, that is also equal to 50 joule per Kelvin per mole. Then the temperature at which the above reaction attains equilibrium is. So now, as you know that at equilibrium, delta G naught will be equal to 0, which is equal to delta H naught minus T delta S naught. So therefore I can say that the temp so T delta S naught, that will be equal to delta H naught. So therefore T we can find that is equal to delta H naught by delta S naught. So now therefore delta H naught is this minus 40 kilojoule. Now delta S naught, how to find? Delta S naught will be equal to the sum of the enthalpies of products minus the sum of the uh, no sum of the entropies of products minus the sum of the entropies of reactants. So that will be equal to, here 2 moles of Z is formed, so 2 into entropy of Z minus here 3 into entropy of Y plus entropy of X. So that will be equal to 2 into 50 minus 3 into 40 plus 60. So therefore the the change in the standard entropy change for this reaction, that will be equal to that will be equal to 2 into 50, that is 100, minus 3 into 40, that is 120 plus 60. So that is equal to 100 minus 180, so minus 80 joule per Kelvin per mole. And delta H naught, that is the standard enthalpy change, that is equal to minus 40 kilojoule. So therefore the required temperature, the required temperature at which the reaction, temperature at which the given reaction equilibrium, attains equilibrium is T will be equal to delta H naught divided by delta S naught. So that will be equal to minus 40 into 1000, since 1 kilojoule is 1000 joule, divided by, so it is joule per mole actually, kilojoule per mole. So per mole divided by minus 80 joule per Kelvin per mole. So the answer will come in Kelvin. So minus minus will cancel, 40 to the 80, and 500, 2 into 500 is 1000. So the required temperature is 500 Kelvin. So it means option 2 is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCET exam on the chapter Thermodynamics. Still, any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent vi videos. Um, and please install our Sapience education application also, where we shall upload some important previous year questions uh, based on the previous year KCET exam, which shall be obviously helpful for your exam. So thank you everyone. Bye.